Good morning, good afternoon. Thank you very much for your invitation. I hope you can hear me. Let me just share with you my screen so that you can see my presentation. So first of all, thank you very much for the invitation. I think for us it's an honor to participate in today's event, and we see what is happening in Korea in terms of urban air mobility. Electric air mobility is fascinating. It's a very interesting dynamic in terms of what comes together from technology, from a regulatory side, from eVTOL development to automated ATMs. And I think that makes Korea a very interesting country on the, let's say, global electric air mobility map. What I would like to use the next 20 minutes is share a bit on Lilium's technology and vision, and how do we foresee our technology will be applied as the so-called regional electric air mobility. Very happy to clarify any questions. Maybe we can use the chat room for that. I guess you have a procedure for that. To myself, very briefly, my name is Conrad Tann. As already introduced, I'm leading Lilium's government partnerships, where we establish strategic partnerships with governments and regions on how to establish regional electric air mobility operations. I've been with Lilium for the last 2.5 years. In the beginning, focusing on our regulatory integration, now focusing more on, let's say, the business development. What is Lilium? Lilium was founded by these 4 gentlemen here on the right side, all aeronautical engineers from Munich, Germany, with the aim to establish an aircraft which is electrically powered, takes off vertically, but also introduces a new kind of mobility without the need of significant infrastructure investments in a sustainable way, but also accessible, which gives high-speed mobility to entire regions. That whole idea came through Daniel, one of our founders, who has been in the aviation industry for quite some time. In 2015, the group found together here in Munich. And since then, I think the company has very much matured from, let's say, a startup to an aviation company. We are more than, it says here, 570, we are more than 650 people focused on the aircraft development, aircraft production, and the commercialization in terms of the service. We have raised more than $375 million from investors, and who will accompany on our path to certify the aircraft and then to make that vision a reality. As mentioned, Lilium has grown significantly, I think not only in size, but also in expertise. What we see here is that our leadership team bundles together all kinds of aviation, automotive, technology expertise, and is ready to execute on that project deliverable. So just to name an example here on the top line, second person on the left, Dirk, who is managing our production activities, used to run Airbus's A380 and A320 family production line in Hamburg. Or also another example is here, Brian on the second row to the very much left. He used to be the COO of the Eurofighter program, a world-renowned aircraft, now is managing our technology efforts, who is our CTO. So what do we see here is a group of leaders in the aviation perspective who comes together and is ready to make that vision a reality. Where do we stand from a technology perspective? And the 4 founders have, in the early years of the company history, very much focused on developing small prototypes, testing out the software, so the vertical thrust, and then the transition to forward flight. I will show you a video later on. And then in 2018 and 19, we demonstrated large-scale aircraft, first with the 2-seater, and then in 2019 with the 5-seater aircraft, which will be the basis for our aircraft in the certification process. How does that look like? I think the speciality of our technology and the uniqueness is that we combine the VTOL capabilities with the capabilities of a fixed wing aircraft. And I think both of these components have crucial items. So what you see is the aircraft with 2 short wings in the front, 2 large wings in the back, with electric engines mounted on top of the wings. Take off vertically, so the engines steer towards the ground, and then go into the transition and direct the thrust towards the back of the aircraft. As soon as we have gone through that transition process, our aircraft makes use of the wings, which generate lift and therefore reduces energy consumption, but also makes us able to travel at much higher speeds. What does it mean? What are the implications we see here? The one side is that as we have 36 engines, multiple flaps, multiple battery systems, board computer systems, we aim or we achieve a very high level of redundancy without any single point of failure. This enables us a much higher safety level than, let's say, a one engine general aviation airplane, where you have critical engines, which if they drop, then you are facing a catastrophic event. So here, that results in a safety level similar to, let's say, commercial airliners, and will also be represented in the certification process. The second thing is that the flexibility of that system. So we are able, what you see here, to fly high turns or high bank angles, but we can increase our speed up to 300 kilometers per hour, but also reduce the speed in order to increase maneuverability. That enables us to, for example, land in different environments. Let's say you have an inner city location with an obstacle-rich environment, or you have an airport location where you need higher speeds to reach your landing site. I think all these flexibilities then have also benefits in the operational part. Lastly, just to touch one topic is noise. Here we are very proud that as our technology is based on electric engines and the ducted fan system, that our engines are shielded, we reach noise levels during the takeoff and landing, which allow us to land in inner city locations by current regulation. During cruise flights, there won't be any noise emissions on the ground. So that's what you've seen here is in the video is our current prototype, and as mentioned, this will be the basis for our aircraft, which we will type certify with leading aviation authorities. What you see here is that the product, the aircraft with which we will enter the market and establish our service. I think we have touched most of the specifications here on the bottom side. I think one thing I want to pick is the payload. So the aircraft will have space for 4 people, 4 passengers and 1 pilot. I think that's for us key, that initial operations, initial electric air mobility operations will be with a pilot on board in order to comply with existing regulatory requirements. And what we also see here is that by launch, we will aim for a battery range of 250 to 300 kilometers, enabling us to establish this regional electric air mobility concept, not only targeting routes within metropolitan areas, but also beyond. But I will come to the application afterwards. How do we see the vision to come in reality? And I think we have looked at many markets around the world, like where do we deploy this technology? How do we make use of it? And when we look at how mobility works today, it's pretty much not has changed its strategy in the last, let's say, many decades. In terms of how do we connect people, is that we have 2 points, let's say A and B, and then you build an infrastructure such as a high-speed train line or a motorway, which requires billions of investment, long lead time projects, high project complexity, and in the end, you have a very linear connection. So you have then established a link between A and B, but as soon as you have a new development beyond that, I think this kind of infrastructure will always have not the flexibility to cope with okay, sorry, I just see the chatting room. How developments will come in. How does electric air mobility, and especially regional electric air mobility, come into place? I think the first one is very much important. What is the infrastructure for our technology? And what we see here is vertiports, which on the one side can be very much adjusted to the respective locations. So in terms of size, in terms of throughput, but also that you can structure them in a way that you are able to funnel through thousands of passengers. So let's say you are talking about a remote regional location in the countryside. You would probably go for the top left option, where you have one TLOF, as we call it, so the takeoff and landing area, with maybe one parking stand where you charge the aircraft. If we talk about inner city locations or locations with high throughput, high demand, then a vertiport design, such as on the right side, would rather apply where you have one TLOF and many parking stands, so that you can make best use of your technology, of the throughput, and establish a sustainable and solid throughput of mobility and capacity. The second thing is that as we are basing our technology on an electric aircraft, and we are aiming to fuel or to empower that technology also with green electricity, we are very much focused on also how will that be sustainable from a CO2 emission perspective. And what we see here is, with current high speed, but also in general mobility solutions, is that when you look at the operations of the mobility, the production of the hardware, but also the infrastructure, we see very strong value propositions of electric air mobility. So during the operations, we have similar electricity consumption as an electric car. The production is also very much similar. Whereas if you also then look into what kind of infrastructure do you need to build a highway, this is where electric air mobility and any kind of air connection gives us a cutting edge and enables regions to establish a sustainable mobility and high-speed solution. Furthermore, I think what also briefly touched in the beginning is very important for us, that we establish a operation, and that we design it in a way that it complies with existing regulatory frameworks. What does that mean? That we are building an aircraft which is certified by the authorities on basis of existing regulation, that authorities know how to certify it, know the means of compliance, know the process. I think that's the first part. Then you have on the left side, you see the air operations. So as we will be carrying passengers in a commercial way, we will be always applying for an air operator certificate, and therefore also here leveraging the existing regulatory processes and requirements required for air operators. Lastly, I think also the aerodromes and the vertiports must be a certified and designated spot in certain regions or areas in order to reach public acceptance, but also to have the safety and the commitment that operators can pick up and bring passengers, and therefore have a structured operation. So all these three components in the end enable electric air mobility pretty much soon to come into place, as as we leverage these existing frameworks. Lastly, what does it mean for Korea? And I think what we see in Korea is, on the one side, a very strong train network, where you have very good connections, let's say, between the Seoul metropolitan area to the south. And I think what we see the application of regional electric air mobility is that we support such high-speed infrastructure and serve routes where a region sees, okay, there it doesn't make sense to build a high-speed train. There it doesn't make sense to build a motorway. So we just build a vertiport and connect these regions. In the end, what we see is that you build strong intercity, but also regional connections, and therefore increase the citizens' radius of life and reduce travel time. I think in terms of Korea, as mentioned already in the beginning, you have a very strong tech environment. You have a strong mobility environment, and we see multiple use cases throughout the country where regional electric air mobility will provide benefits to the public, to passengers, to governments, and create a totally new industry. And very much looking forward how in the next years the space in Korea will develop. Thank you very much for your time. Maybe I have a look at the chat room.
Thank you for your wonderful presentation. So I guess we have many interesting questions, as you can see from the chatting room. So let me read the first one. I guess the first one is about the ducted fan. So the question is about the questioner and ask about the ducted fan should be optimized for I guess the performance as well as the noise regulation. And then he'd like to know a little bit more detail of the system design. And plus, he's quite curious about which company is producing your motor system.
Yeah, so in general, the aircraft design from an overall concept, but also when looking at the electric engines, are optimized for a range of dimensions. So one is speed. Speed of the aircraft, the faster you are, the more people you can transport, and therefore higher passenger throughput, which also has then business implication. The second one is range. I think as soon as you increase range, then the variety of use cases also increases, and the value proposition is also a different one. Then thirdly is definitely payload. That you can increase the number of people you carry, but also, which I think for us is very important, safety and noise, and the third one, simplicity. So when looking at the ducted fans, in terms of the safety that we have, the shielding of the fan is a strong value proposition for certification, for that not one engine can harm the other one, but also from a noise perspective, the shielding is in a way optimized that you direct the noise in a way that reduces the emissions. And lastly, I think simplicity, as we are talking about electric engines here, I think our aircraft has less parts as a total aircraft than a gas turbine engine. So I think that's for us very important. And as the less parts you have, the simpler your aircraft is designed, the more robust it is also, which has then maintenance, repair, and overhaul implications. From a development or perspective, most of the engines and how do we design those are in-house designed. Of course, we have a range of partnerships, supplier partnerships. Some of them have already been announced. There will be further announcements. So for example, Toray, a carbon composite manufacturer, has been announced as a strategic partner and delivering structures for our aircraft.
Okay, thank you, Mert. And then we have a second question from actually the previous speaker, Dr. Chang from KARI. So the first one is asking about what's the flutter speed, and then how fast actually has the aircraft has flown.
Yeah. So in terms of those very detailed technical questions, very happy to connect and liaise on those. In terms of the flight testing we are currently conducting is that we reach speed 50 to 100 kilometers per hour. And what we've seen is that we have tested the aircraft in multiple environments and see here that there's a high confirmation of what we've engineered and assumed in the initial, let's say, theoretical part, and very proud that the aircraft is able to deliver on its theoretical.
So there are a couple of more very detailed questions from Dr. Chang as well. So the second question was, when do you expect to have obtained type certification?
Yeah, so we are aiming to establish electric and commercial operations by 2025. So in the next 4 years. Within that time frame, we will reach the type certification objective, or we will reach the type certificate and establish first commercial operations in order that we have first networks fully in place by 2025.
Okay. So third technical question is, are you considering AEI, which stands for All Engine in Operative?
So I guess that depends very much on the regulatory requirements. So for example, with EASA, we are very much working on the ops requirements, and there also then the events are defined whether or what is the integrity of your engines and so. So it depends very much on what is the regulatory requirements, and then we comply with those.
Okay, so last question is about ESTA. So the question is about, are you having any difficulty with the certification from ESTA at the moment?
So I think the type certification program with EASA, I think is a very thorough and challenging or demanding process. We are in close liaison with EASA, and it's a very close partnership where we engage heavily from a technical side. I think with every other kind of TC process, it's always that you have to deliver on your objectives. So I wouldn't say that it's specifically difficult. It's a novel technology which we are currently here certifying. So it comes with certain tasks, but we are very happy with our liaison and very much looking forward on the continued work with the respective authorities.